All right, it looks like our attendees are starting to level off here, but folks will still be able to join, obviously, throughout. Um, but as we're now a minute past the hour, I think I'll go ahead and get us kicked off here. I'm Max Herzog, Program Manager with Cleveland Water Alliance, and I'm just kind of kicking things off here. We have a unique format for this edition of Water Data Forum, where we actually have a bit of the panel discussion here recorded via video. So we're just going to play that back here in a moment. I'm just going to get the sharing settings set up. And then we do actually also have a number of our panelists here on the call for live question and answer after the fact. And I think this video is only about 35 minutes. Yep. So we should have lots of time for Q&A. So please do stay tuned for that. So I'm going to go here and I think it's share, computer sound, optimize for video clip. That all seems right. So I'm going to ask maybe Elkin or Sam, anyone who wants to chime in once I play this to let me know that's coming through.
Hello, welcome to the Water Data Forum.
Elkin, can you hear yourself? Is that working?
Yes, sir.
Awesome. All right, I will hit play.
Today's session is the finger on the pulse, next generation asset health monitoring for smart utilities. The Water Data Forum is a free 12-month virtual series presented by the Cleveland Water Alliance, the Water Environment Federation, and the Midwest Big Data Innovation Hub. These interactive web sessions engage sector experts in an exploration of utility, private sector, and research approaches to collecting, managing, and measuring water data for impact. My name is Elkin Hernandez. I'm Director of Maintenance Services with DC Water, and I'm also the chair of the Intelligent Water Technologies Committee with WEF. At the end of the session, the format of today's session will be a panel with 3 members, a moderator, and 2 experts. And at the end of the session, you will have an opportunity to submit your questions on a Q&A box, as indicated below. So let me introduce our panelists. First, we have Mr. Jeremy Boren. He's the brand manager of Gray Matters. Jeremy Boren has worked as a writer, editor, video producer, and podcaster for more than 18 years, both as a newspaper journalist and digital marketing professional. Jeremy earned a bachelor's degree in journalism from Ohio University and a master's degree in public management from Carnegie Mellon University. We'll have today with us Nina Chetri. Nina Chetri is founder and president of Ensuras Inc., a company specializing in advanced analytics and artificial intelligence solutions for optimizing wastewater plant operations. Nina has over 15 years of wastewater treatment and engineering experience. She received her bachelor's and master's degrees in environmental engineering, both from the MIT, and is a licensed professional engineer. She has a passion for advancing technology to help secure water for current and future generations. With us today, also, we have Mr. Kenel Kasim. He's the Vice President of Digital Utilities with Gray Matter. Kamel has over 15 years of experience with Gray Matter and significant experience in water, wastewater, oil and gas, and power industries. Prior to joining Gray Matter, Kamel spent years as a successful consulting engineer in the water and wastewater market. He also worked on commissioning power generation plants at Babcock and Wilcox. Kamel specializes in asset health monitoring using machine learning and digital twins to deliver business results for utilities. With that said, please let me welcome today's panel.
Okay, thanks for that introduction, Nina and Kamel. It's good to be here along with you today. I think we're going to have a great discussion on analytics and water and wastewater industry. So let's jump right into it and start off. Kamel, if you want to give us a bit of an introduction to who Gray Matter is and what Gray Matter does, and then we'll go to Nina.
data in the cloud, connecting different plants together, pulling data back to a central location, especially in water, wastewater. Air gapped has been the way to go. And now we're seeing more and more people need that data back to engineering or into an analytics package. So cybersecurity is critical for that. Around brilliant operations, that's understanding quality, uptime, where your problems are at. And then, of course, advanced industrial analytics is what we're going to be talking about today. And that's been the big focus for many of our customers over the years. We've been able to tell people what happened, which was key for a lot of people. And now people want to know what's going to happen. And we're helping them out with the advanced AI.
Absolutely. Thanks for that intro, Kamal. Nina, you want to tell us about your company, Ensuras?
Yeah, so Ensuras, we are basically wastewater engineers and advanced analytics and AI experts who develop AI and ML-based solutions to solve problems and optimize operations at wastewater plants. I started this company in 2017, and that has been the core mission ever since the company started. In my background in the wastewater field, I started off designing wastewater treatment plants as a process engineer and then as a project manager building and commissioning these facilities. It was very clear that we had a lot of useful data that was being gathered at lots of our facilities. We have data gathered from automation systems, data gathered for regulatory compliance purposes, and data gathered for keeping a pulse on the process treatment scheme. And this data is valuable data, but we're not really doing much advanced analytics with it. And so that's kind of where the idea for Ensuras was born. And we currently offer what we call our AI wastewater stack. And all of our solutions are, the foundation is the data coming from various parts of the treatment plant, whether it be the actual physical sensors and meters, whether it be the laboratory data, whether it be the field data, whether it be data from publicly available sources like weather. That sort of forms the backbone of all of our solutions. We can provide facilities with the hardware, or we can come in and use the existing data that's already being collected. The core of our system is the algorithmic work that we do. So we'll work with facilities to address particular problems that they're facing using the data that they're already collecting or specifying and providing that hardware to collect the data that we think will be beneficial to solve that problem. And we develop analytics specific for wastewater. So a lot of the times our solutions involve a combination of wastewater engineering solutions with data-driven solutions. So I think that's kind of where we provide some, really unique value add. And more and more, we are providing an analytics and insights delivery platform to make our solutions more readily accessible to operators in their daily workflow. So, we've worked on projects where we provide all three of these layers, or we might just provide two of the layers, but we're providing, as per our customers' needs, this kind of a AI stack solution to solve problems specific to wastewater facilities.
Great. All right. Well, thanks for the intro. So today's format, we're going to be exploring 5 questions that were part of the agenda that everybody used to register for today's event. So let's just get into those questions and start the conversation. So Kamal, we'll start with you and then we'll go with Nina. So what are the major considerations in utility asset health monitoring and O&M in this space? Kamal, you want to go ahead?
Sure. I think one of the first things is understanding what is your current state. How do you, when a problem happens, how does that get to the person that needs to fix it? So I think as you're creating a plan and going to improve it, the first thing is to understand your current state of how things are operating. And then what are the biggest issues that you want to solve? And I think really key is, do you have a goal that's baked out that everybody agrees to and is going to work towards? If you don't have the people that are on the front line that are going to be touching the wrenches, If they're not behind your plan, then some of the best work that you do and the best predictions that you do aren't going to make it to that person and get them to do what you need to do. And then once you've done that, is what is your infrastructure? Are these sensors in place? You go in, you buy a piece of software, you think it's going to solve your problems, and it turns out you're only monitoring vibration once a month when somebody comes in and takes those vibrations. And understanding what is it going to be the total cost of a system, including the infrastructure, the sensors, and then getting everybody on board through the training, and make sure that it's are you willing to how are you going to eat the elephant, and are you ready to do that? And if you're not, then you should work through that before you continue, for sure.
You got to set yourself up for success, for sure.
Yeah, and before you start, know how that alert is going to get to the person that is going to be able to do the work, and make the correction before there's downtime or something is operating inefficiently.
All right, great. Nina, same question to you.
Yeah, so I think that with the water and wastewater industry, we are currently undergoing a digital transformation, and it's drawing on new technologies in a range of fields, from connectivity, mobility, automation, and data analytics. And so we're finding ourselves in a place where we can use AI tools in ways that were previously not possible to assist operators. And when I look at asset management and plant operations, I mean, these tools can be integrated across the board, from managing the assets both within the plant boundary walls and also within the collections and distribution system. And we're finding that I'd say there's been some traction in that domain, especially with distribution system asset health monitoring and identification of leaks to reduce non-revenue water losses. And so, there's been a lot of traction in that space. A lot of utilities are adopting advanced metering infrastructure to address problems with regards to managing that distribution system. It's also helpful in terms of a tool to engage with customers. A lot of utilities customers are finding that kind of data helpful to them, and it's a way to add value to the customers that utilities serve. But then also, if you look within the plant operations itself, there's opportunities to change the way utilities are managing their assets there as well. For example, we have, in the water and wastewater facility, our infrastructure is getting old. A lot of facilities are in need of upgrades. We're also finding that a lot of facilities are needing to expand their capacity or meet more stringent discharge standards. So, incorporating these tools into the plant operations so that we can really be smart about where we're putting our resources and deploying our resources. Like maybe we can manage our stormwater in ways where we can, be able to treat more. If we identify I&I leaks, we can be able to treat more with the existing infrastructure. So just kind of, I see these tools being, having applications across the board, increasing our plant's revenue. If we operate in ways that we can identify water losses, if we operate in ways where we can reduce our operational expenditures, we're actually impacting the bottom line. And in facility planning and growth, if we can use this data that we're collecting to better model our projections for what we need to grow and treat the populations surrounding our facilities. These are all areas where we can start to use these tools. So when I see, think about how this relates to asset health and plant operations, we're starting to see infiltration of these tools, but they can be applied to many number of aspects of water and wastewater utilities.
For sure, and I think you hit it with capacity. We see that all the time at Gray Matter, just people looking for for ways to deal with that increasing capacity needs. So we'll move on to the second question, and Nina, you can take this one on first. So how can machine learning and artificial intelligence, help? I think you started to answer that question already, but you can go a little deeper on it.
Yeah, I think that, artificial intelligence and machine learning can provide a benefit, but it's a change in mindset to how we operate facilities. And so, there really is that need for buy-in and acceptance of the operators, the frontline workers, to sort of use these tools to make them better at doing their jobs, and view these tools in a way that provides them with that kind of assistance and support. And I think the real value for AI ML based tools is to move away from reactive decisions for operations and maintenance and more towards predictive and prescriptive decisions for operations and maintenance. So, I already kind of described the rationale for us starting Ensuras was that there is this wealth of data that we have available to us. So now can we use this data to change the way we operate so that we're informing our operators of more optimal set points, critical set points within the facility. And can we use this data to actually predict where we might have issues in meeting our discharge requirements? And can we deploy our resources in a way where we're not just going through our normal schedule of repairs, but actually directing the resources to places where repairs are most needed. So we have this data, and I think that there's a lot that we can do to change our mindset for how we operate our facilities to be more analytical and less kind of rushing to fight fires, where we have equipment that's down, deploy our resources. Where we have, clog in the pipeline, okay, let's go deploy resources. Where we're seeing our plant is slowly, reaching the limits of our discharge standards, okay, let's assess what's going on. So, rather than kind of this reactive approach to operations, really kind of being more proactive and using the analytics to get us there is where I think AI and ML really have a role to play.
Yeah, absolutely. And Kamel, you said it in your intro, people or organizations used to just ask, what's going on now, but now they want to know what's going to happen. So can you talk about how AI ML can help?
Sure. So today what we see is many of our customers are still doing maintenance based on a calendared approach. And the people that are near the advanced end are looking at the at least runtime hours. So one of the challenges there is getting the runtime hours from the SCADA equipment into the CMMS systems. And runtime hours are much better than a calendared approach. But where AI can really help out is, as if you drove your car 10,000 miles on the freeway, it's not going to require an oil change nearly as often as if you were driving in, downtown New York City every day as a taxi cab driver. And that's where AI can really help. It's, looking at the fleet and then looking at the equipment and doing the maintenance on the equipment based on how the equipment has been living its life, as opposed to just the number of hours. And certainly you don't want to be doing just an every 6 month approach. So I think that's the big thing for AI, is being able to see how the equipment has been living, see how other equipment has reacted in similar situations. Are you using more power to do the same amount of work? That's a big indication that piece of equipment is going to fail before too long. So those are great use cases for AI and where they can help out.
Absolutely. All right, so let's move on to question 3. So how is this different than business intelligence dashboards? Those BI dashboards, they get a lot of attention. You often see them, but it is fundamentally different. So Kamel, could you kind of take us through how AI ML and what people see from it differ from business intelligence dashboards?
Sure. So with the business intelligence dashboard, again, most of what you're looking at is a current state, and you're not looking at what's going to happen. Ironically, we are taking some of this analytic data because BI tools are great tools in these dashboards, and people are looking at them. And what we've been able to, you have the situational awareness rooms where people are monitoring maybe on a county-wide basis what's going on. And we are actually, not to mess up the question here, but we are actually taking analytics and putting them into some of these BI dashboards. So it doesn't have to be an either or. The key is this is where people are looking, and then giving them analytics. And like the trend that we're showing here is we're comparing actual to what the prediction was and showing how tight the prediction can work. But I think the big thing is that just having the BI dashboards without the analytics, that's not going to get you where you want to go. But being able to put the AI insights into your BI dashboards, that's where we're seeing people making some really leap forwards.
For sure. Nina, same question to you. How does it differ from those BI dashboards?
Yeah, just like, Kamel pointed out, BI dashboards are a graphical representation of the underlying state of the business or organization. So essentially, it's a visualization of raw data. And, that definitely has a role to play. It's definitely more helpful to see a trended graph or a visualization of raw data to quickly understand that data. But it's not advanced analytics. Advanced analytics is using methodologies from machine learning, AI, and statistical signal processing to gain insight into plant performance and drive operations and planning. And, as our utilities get more complex and as we get more and more raw data, it'll be easy to get inundated by that raw data, whether it's visually represented or not. And, we talk about optimizing operational expenditures. Well, operators' time is valuable, and we need to be able to direct that operator's time to areas where we need the operator's attention. And so that's where I think advanced analytics really has a role to play, and where it differs from the business intelligence dashboards. We're actually providing that actionable insight to the operator where they need to, divert their attention, whether it be, looking at an anomaly, whether it be changing an action at the facility. So really taking that raw data and parsing it so that we're bringing the most important insights to the operator and utilizing that operator's attention in the most, efficient manner possible is where I see the main difference. And before we get to advanced analytics, obviously we need the raw data. So if you don't have the raw data, if you don't have that ability to generate a business intelligence dashboard, then you can't go to the next step. So it is a requirement, but it's not the end all be all. Once you get there, what next? Because it's very easy to then just get inundated with that data.
Right, not either or, it's both. Yeah, for sure. All right, so our fourth question today, what impact might AI approaches have on the workforce? Nina, do you want to take that one on first?
Yeah, sure. I think that the water and wastewater sector may be a little behind other sectors in applying advanced analytics tools. But when we look at other fields, and this study was done by MIT to look at, in businesses, the top performers tend to use more analytics in decision making versus the lower performers. And so the adoption of advanced analytics actually does help. And we've seen this in other industries and other sectors. So there's no reason to believe that this kind of optimization or improvement wouldn't be experienced in our own field. If you look at activated sewage treatment facility, activated sewage treatment facility, there's a wide variation in energy intensity. And that leads us to believe that some facilities are operating more optimally than others. And, right now we may not be optimizing operations. Maybe we're more focused on just meeting the compliance and the regulations. But as we adopt more advanced analytics tools, there is, in other industries, a demonstrated improvement in performance. And, I think this is coming at a really important time for our field of water and wastewater, because we are seeing that a lot of our workforce is retiring or is eligible for retirement. And so we're going to be having a new, younger workforce come in that, is likely more comfortable with, the kind of tools we're talking about. And there could be an opportunity to really make that transformational shift and provide these tools to operators during this kind of phase that we're going through in our industry. And I did want to sort of underscore the fact that AI is a tool. It's a tool to help operators. It's not there to displace operators. There's some things that operators and humans will always be better at doing, and there's some things that computers will always be better at doing. When an operator walks around a facility, he or she is using his or her senses. I mean, the smell, the sight, the sound, all of that is important data that's coming in. And, we cannot replace that with a machine. But crunching numbers and dealing with this large quantity of data to generate insights, a machine can do brilliantly. And so it's really a form of augmented intelligence that's meant to help operators do their job better. And it's going to be increasingly important as operators are being expected to do more and more, and plants are being expected to do more and more, whether it be, recycle and reuse of wastewater, or more stringent nutrient standards, or, trying to make the existing infrastructure work for a greater increasing population of people. So, I think these tools are really, have demonstrated that they help us perform better. And I think that it's a tool that the workforce will hopefully in our sector continue to embrace more and more.
For sure. So Kamal, how can it help operators do their jobs better? What's the impact of advanced analytics in water, wastewater?
Yeah, I think it's operators, it's maintenance people, it's supervisors. It can help everybody. One of the things that's greatly increased the efficiency of everyone. If you're not spending time putting out fires because something broke, as Nina mentioned earlier, then you're going to be more if you're doing things as a planned event. Everyone hates when you take a piece of equipment apart for some planned maintenance, put it back together, start it back up. A week or two later, it fails, and it's something that would have been very easy to replace had you known that this bearing was wearing out while you had it down replacing some seals. So I think that's where AI can really help, and also streamline from when you do have a problem, streamlining that from an operator seeing it on a screen instead of them picking up a phone or writing an email or writing a note down and the maintenance person looking at it later and then getting into the schedule. That AI helps prioritize that schedule of what should be worked on and when it should be worked on. So again, greatly efficient, helping out with efficiencies, that you're working on the most important things, not just what you think are the most important things, but what the equipment is saying. I'm the one that's going to cause problems here in a little bit, and you can wait till you take me down, but when you do take it down, make sure that you replace these bearings while you're in there because of the increased vibrations.
Yeah, great point. And also there can be a bit of a leadership component here too, right?
Yeah, because again, you're directing people not to keep putting out fires, but you're directing them, and everybody is much more calm because everybody's calmer when there's not a fire. When there's a fire, there's a lot less calm, and I think it can really make your job less stressful. When you come in and you think you've got a plan, you're going to do this, people are getting after you because you're not getting done your work because Monday through Wednesday, you were rebuilding something you didn't think would have to be rebuilt. These days, with the supply chain issues that we're having also, it's even more important to plan ahead, knowing that the bearings are getting ready to fail. We'll order the bearings. We're going to take the equipment down for some planned maintenance in 2 weeks from now, and we're going to do this work, and we'll have the bearings there, as opposed to it's down now and it's weeks before we can get the parts to repair it.
Absolutely. So fifth question today. So what impact might AI approaches have on environmental sustainability? Kamal, you want to answer that one first, and then we'll go to Nina?
Sure. I think we've covered a lot of these already, but they're great points to touch on again. And one of the easiest ones are, if a piece of equipment is using more energy than other customers use, or even another piece of equipment sitting right beside of it to do the same work. So the watts of water idea, how much water can we treat and how much power did it take us to do that? And getting that power down as low as possible, that's great for sustainability. We're also seeing a lot of chemicals are dosed, flow paste. It's just based on this is as much water going by, and everybody's going to err towards not making the news and making sure that they use as much chemicals. They don't want to make the news that way either by putting too much chemicals in the water. But you're not going to, where a manufacturing plant can really lean things out. They just haven't had the confidence. And I think with some of the great AI tools out there, the increase in sensors, you're going to be able to treat it based on what it is. So different times of the season, different sources of water, all kinds of things can have a factor. And if you're monitoring more closely, you're using AI to help you plan on, what's using more power now than it was, how little chemicals can we use. And I think that's great for sustainability is less power, less chemicals, and more clean water.
Yeah, and if you're customizing your approach, you're not reacting, or at least hopefully you're not reacting as much. Yeah. All right, Nina, same question. The environmental impact, how can it help?
Yeah, I think that, there's two aspects to this question. I think, like, number one, water and wastewater facilities are designed to protect environmental and public health, which in of itself is a sustainability, topic. And I guess, I thought I'd sort of share some examples that we've worked on or we're currently working on, just to make facilities, meet their goals for discharge standards, is in of itself protecting our environment and public health. And I think, we've seen an opportunity in particular in smaller distributed systems where they may not have full-time operators. I think that, we see that those smaller facilities tend to have more compliance issues and may not have the expertise that they have at larger facilities, or even the staff or resources that they have in larger facilities. So, AI/ML could be a tool that's used to help lower the cost of monitoring those facilities. We talk about distributed treatment, as having applications in, rural settings, but maybe we incorporate more centralized management and monitoring of these systems using AI/ML approaches to ensure that they're doing their job in protecting the environment and human health. So we don't have those violations that we tend to see in smaller systems that are more resource strapped. I think we can also see sustainability as an approach to really even in larger facilities, and we worked with even very large facilities to predict events of concern and address them. So can we prevent our nutrient limits from being exceeded, or can we prevent a CSO event? All of those have a direct impact on the environment and or public health. But then, there's a secondary component to this question as well, which is the actual sustainability of the facility itself. And I think that as we are seeing facilities have more environmental goals or climate goals, that's an increasingly important question. And it's increasingly important to see if we can operate our facilities with these goals in mind. So, we can optimize purely around compliance, but with more sophisticated use of advanced analytics, we can optimize around compliance and energy consumption, or around compliance, energy consumption, and chemical consumption, or around compliance and greenhouse gas emission reduction. And so I think that as we have facilities more focused on potentially reducing their operational expenditures, which, it just so happens that, energy and chemical use is also a high cost item. So we're not just meeting our sustainability goals, but we're actually reducing our operational expenditures. Or we maybe do have sustainability goals and objectives to reduce carbon emissions, become net zero in carbon emissions. So these kind of goals can, be addressed by optimization in real time around these goals, whatever they may be. But I think that the move away from simply compliance-related goals and goals that encompass sustainability is clear, and AI and ML can help us get there.
Yeah, absolutely. Well, Kamel from Gray Matter and Nina from Ensuras, I really appreciate the discussion today. I'll turn it back over to Elkin.
Thank you, Jeremy. Before we move into the Q&A session, I'd like to mention that this session is being recorded and it will be available free of charge at the Cleveland Water Alliance website within a few days. I also like to mention that we have, this is the 10th out of the 12 sessions for this year. And we have 2 more upcoming. In November, we have a session on the federal water data standards, impact, value, and challenges. And in December, we have the real-time revolution, innovation in water quality sensing. We hope you guys can join us there as well. With that said, let's move into the Q&A session. And please send your questions at the box that you'll see in the lower part of your windows. Thank you.
Hello, so this is me back, this time live. Thank you for everybody attending the session. I'd like to start going through some questions that we have here. We have received at least a few, and please encourage the people listening to us to send your questions live. We'll try to do our best to answer them. So we have 2 very specific questions. We'll give it a try. One is, and I'll make the question open to any of the panelists. One is from, it says, can the AI tools be implemented to determine the effects of seasonal factors, such as freezing and thawing in both drinking water distribution and sewer flow? So can we include seasonal factors into the AI? And I'll leave it open to the panelists, please.
This is Nina, and I can take a first crack at this. So, oftentimes weather is an input in the AI ML that's developed, and so it does take into account diurnal, variation or seasonal variation. And so that is something that if there's a problem that is, we know from, engineering and our domain expertise in the system, weather has an impact on, then it would only make sense to develop the models that take into account weather as a factor. And, further, in terms of monitoring the system, if we know that temperature is something that impacts the performance, we can even add, if we're not already collecting temperature data to gather that insight. So, I think that weather and seasonal variation is something that, impacts a variety of problems, and using that in the training itself is warranted when it is impacted by weather.
All right, thanks, Nina. Certainly makes sense to that AI can benefit from the data sets available on weather information. That's one of those data sets that tend to be very complete and available. We have another question which might be a bit challenging, but I still want to put it out there. It says, what open source AI models and data sets are available for pump vibration analysis? And if we know of any of those, any idea on the URLs, but that may be available?
Yeah, I'm not familiar with any off the top of my head.
All right, that makes sense. What I would note there is that for a long time, these used to be very closed systems, the ones used for vibration. And I can see that there's a trend to expand on the use of analytics into vibration. So if it's not available today, I think that down the road, that information, that type of data sets and models might become available. So I would keep my eyes open for them.
I think the fact that the vibration sensors are coming are coming down so much in price that that may open that up, where in the past the vibration equipment itself was very expensive, so more than likely it would be a proprietary AI tool to analyze it. But with as inexpensive as vibration sensors are, I think you're right that some of that may be coming.
No, that's certainly as one of those sectors that is benefiting. It has a great benefited a lot from the upcoming ML and AI technologies, and certainly one that's being disrupted by new technologies. We have another question. It says, how well instrumented are systems today? How does this impact the implementation of AI and ML?
I'll take that and start off that one. I think that many systems that they're designed today based on the data requirements of the past. So things that you needed to store, turbidity, and then that's why we do so much flow pacing, is because the lack of instrumentation and being able to know exactly what's in the water as it's going by. And I think that's key, when you're looking at doing analytics or machine learning, is looking at what data do I have today, and is it enough at a high enough resolution to really to give me the information that I want. And we encourage people to start off there before they want to get too far along with the software. Do I have enough instrumentation or not? So what we've seen is it's limited. It's limited.
Yeah, just to add, I think.
Go ahead, Nina.
Yeah, I'd say I think there's a large variation too between like larger utilities, where I feel like they may have more real-time data and more instrumentation versus some of these smaller utilities, which may have little, if any, real-time data. So I do think there's a large variation there. I think that, one of the things to look at is, with your existing instrumentation and data, are you well positioned to solve some of the challenges that you'd like to solve? And sometimes what the utility is collecting could be sufficient in of itself to start to address certain problems that they might be wanting to address. If it's a smaller facility or a facility that has limited real-time data, it may not be that you have to, install many dozens of sensors. You could, depending on the facility's, again, goals, install a few sensors and still start to make some headway in advanced analytics. I think one of the things that the water and wastewater industry differs in with respect to its data is, the quantities are much less. So when we say big data, we might be talking about, hundreds or thousands of data points in our historical training data set, as opposed to millions. So, we have worked with that size of data and seen good results. So, that's just a characteristic of the water and wastewater utilities. We have, less quantity of data, but we do have data. And I think that depending on the facility, oftentimes it's sufficient to start making some headway in advanced analytics, depending on the problem that they're looking to address.
Thank you, Nina. I would add just one comment. I think when you're trying to embrace ML or AI, you may want to define your goals and work that way towards your data needs. With a caveat, is always allow some room for exploration, because there are initiatives that end up being just exploration, and if you don't allow that possibility, you may be it may become a frustration at the end when you think you failed to achieve a goal, knowing that just exploring and learning whether it was achievable or not, practical for you or not, by itself is part of the task. I have another question here. It's an add-up on the previous one. It's asking whether do you guys see whether the adding instrumentation and sensors is cost prohibitive? Is that something that is really not viable, or is practical? What's your take on that?
I can take a stab at that. But I feel like for plants that are already in existence, adding sensors can be a challenge because it has to be added into the annual budgets that are approved and approved once a year, and getting onto that, even a small cost item, and depends on the sensor, obviously the cost of the sensor, but it can be difficult to add it unless the facility is going through an extensive upgrade. And I think it's good to, if the best times to add it is when you're conceptualizing a facility and building it, greenfield project, or you're upgrading a facility. That's a good time to think about how you can become more in a position to use more AI tools. But underscoring that's why we try to work with the data that's already being collected at the facility. And if it's just a matter of a few sensors being installed, I think that can sometimes be something that can be accepted by the utility. But a large scale change usually happens at certain times during upgrades, expansions, or when the facility is being built.
And just to add on to that, we've got a very prescribed approach that we take, whether it's water, wastewater, or whether it's any industry, and that is to start with the problem that you're trying to solve. We have to try to dollarize that problem and basically understand is what's the cost if we don't do anything? How much will it cost us? And then based on that, then you can determine, you have the AI, you have whatever it's going to take to operationalize the insights once you get them. And then also what equipment or sensors that you would need to add and what infrastructure you would need to add to feed the right data to the analytics. So understanding that up front, start off with a small pilot, see what sensors and that will be needed, required for a rollout, and then understanding what your total cost is to get started. And that's a prescribed approach that we take with customers. And we have had customers that we have said, look, your problem isn't worth, the juice isn't worth the squeeze for this one thing you're trying to work on with the instrumentation, the infrastructure, and everything else you'd have to do. It's not a good choice for you. And 90% of the time it is a good choice. You just have to add a few instruments and get that data into the AI tools.
Thank you, Kamel. I have an interesting question here. It says, what are some common misconceptions about advanced analytics that you have encountered?
I think one of the biggest misconceptions we run into is that people think once you get some insight out of a model that you've accomplished something. And the insight out of the model is really just a start. If you can't operationalize that and get that to somebody's hands that can affect the process to reduce the energy, to reduce chemicals, if you're not taking advantage of the insights you get when you're working on equipment, and when a piece of equipment is down for maintenance, you're doing other things to it that you have the machine learning said you're going to have a problem later down the road. So I think that's one of the biggest misconceptions is, well, we've got tools that we get the insight from, but if you can't operationalize that, you had no ROI at all because you didn't affect the process. So I think that's one of the biggest misconceptions.
Anything to add, Nina?
Yeah, I think that, again, I think I mentioned this in a previous question, but the amount of data that's required to start doing AI ML, in our industry, I think is a lot less than other industries. And there could be a misconception that we just don't have enough. We may only have been gathering this one data point once a day for, a year, and that's only 365 data points, or we may only be gathering every 15 minutes and for a year, and so what I would like to underscore is that's our industry. That's the level of data that we gather, and we can start to make insights and advances with that, even if we're not talking about, necessarily large amounts of data. One thing we do have is a very diverse variety of data. And I think that that's interesting and unique to our field. Although the quantities may be on the lower side, but we can still, and we have seen that we can do, that is sufficient to start using AI ML for making decisions.
I have another question. It's very general, but I think it's worth asking it. And by the way, we're just starting to wrap up this session. So the question here is, how long does it generally take to build and implement an analytics program?
Yeah, I can answer that. So, if it's an existing facility that already has historical data, then it can be relatively quick if the goals are clear. If you already have historical data and you have goals and objectives that are clear, then the models can be developed using the historical data, and you can have some solution up and running within a couple of weeks. If you don't have historical data, then we come to the point where, okay, well, we need to start collecting that data, and that may make the lead times a little longer. But it can be relatively quick if there's data available and there's a goal that's clear as to what the objective is.
I agree with Nina that we have seen in cases with good historical data, within the first couple of weeks, you put the data through the models, you're understanding what variables are the biggest factor in the problem that you're chasing, and you can get some insights within a couple of weeks. And then usually within 4 to 6 weeks is when you start being able to get that data back down to somebody that can affect the process and make the changes. And then you can start rolling that out. But I think one of the key words in your question was program. And I think if you go into this thinking there's a stop and there's an end, you may be looking at it the wrong way. I think it's more of a journey than a sprint. And usually you solve the one problem, and then as you get better and better with it, you just continue looking for things that AI and ML can help you with. And I think a lot of our clients, you definitely don't see it as a start and a stop. It's chase the biggest problem, get the most ROI, put that back into the program, and just continue. And a lot of these things, as you know, around sustainability, if you stop tracking things and stop doing things you thought you're done, you will, studies have shown that you end up reverting back to the state that you were originally. So I think the idea of program is that you need to make it a continuous thing that you live by every day, as opposed to a start and stop.
Thank you, Kamel. So that was our last question. I have just one final comment. There's somebody who likes to learn more about the specifics of the offerings on Gray Matters and Ensuras. So I will suggest you reach out you can reach out to directly to Nina at ensuras.com. Nina, if that is correct.
Yes, that's
Nina
correct.
at ensuras.com. And in case of Gray Matters, I would suggest you reach out to Mr. Jay Boren, JBOREN at graymatterssystems.com. And that you can find more specifics about their offerings. Other than that, I just want to say thank you for the panelists for your time and effort sharing your knowledge here. And thank you for the people that attended the presentation. We certainly appreciate your interest, and I hope you guys can join us on the next session on November. So thank you, and have a wonderful rest of the day.
Thanks for having me.
Thank you so much.